Welcome to The Explainer. Man, if you've been trying to keep up with the world of AI agents lately, you are probably drowning in an absolute alphabet soup of protocols. We keep hearing about MCP, ADK, A2A, ACP. It is honestly incredibly confusing to figure out what you actually need to build a functional, reliable AI system. Well, today, we're going to cut right through that noise. We are breaking down two of the absolute biggest players right now, the Model Context Protocol, or MCP, and the Agent Development Kit, or ADK. We're going to demystify exactly what they do, how they are completely different from one another, and most importantly, how they literally snap together to build a complete enterprise-grade AI ecosystem. Okay, let's dive into this. Here's the roadmap for today. We're going to start with the AI integration problem. Then we'll look at MCP as the universal connector. Next, we'll see exactly how ADK structures the agent, contrast MCP versus ADK, and then finish up by building a complete, real-world stack. All right, Section 1, the AI integration problem, and overcoming the connectivity crisis. Before we can really appreciate the solutions here, we have to look at the absolute nightmare developers face when deploying large language models into the wild. An LLM is brilliant, sure, but by default, its knowledge is completely frozen in time, and it's totally isolated from your digital ecosystem. So I want to pose this question. How do AI agents actually connect to the outside world? Like, if you ask an AI assistant to check a database, summarize a live Slack channel, and update a Jira ticket, how does it securely reach out and actually do that? Historically, developers literally had to write custom, incredibly brittle code for every single integration. And honestly, this problem is so urgent that the entire industry is going through a massive, rapid shift. Just look at this adoption rate. According to recent data from April 2026, a whopping 78% of enterprise AI teams already have an MCP-backed agent in production. That is a staggering adoption rate for a technology that Anthropic only just introduced in late 2024. So why the mad rush? Well, because the old way of connecting agents is fundamentally broken. The old way creates what developers call the N by M integration problem. Just imagine you've got 3 different LLMs in your company, right? And you want them all to talk to 5 enterprise tools, say a CRM, a calendar, a ticketing system, a knowledge base, and a document parser. Under the old method, that requires 15 custom hard-coded API connections. It's just a brittle, unscalable web that is an absolute nightmare to maintain. Literally, every time a single API changes, your entire agent breaks. Which brings us to Section 2, MCP, the universal connector. This is basically the USB-C of AI tools. So what is Anthropic's elegant solution to this massive vertical connectivity problem? Let's define it clearly. The Model Context Protocol is an open standard from Anthropic, and it enables AI models to securely connect to external tools, data, and resources via one unified interface. Think of it like a universal tool belt. Instead of teaching your AI how to speak the very specific language of Salesforce and then teaching it the specific language of GitHub, you just plug the AI straight into MCP. It's an open JSON RPC-based standard that normalizes how agents talk to the outside world. Okay, so how's it actually built? Well, MCP has 3 core architectural components. First up is the host application. This is where your agent actually lives, like Claude Desktop, or maybe a coding IDE, like Cursor. Inside that host runs the MCP client, and that client manages one-to-one sessions with the final piece, external MCP servers. Now, these servers are what actually expose the specific tools and read-only resources, whether that's just a local file system or an entire remote Slack workspace. Let's just walk through this invisible handshake step by step so you can really visualize the lifecycle. Step 1 is request and discovery. The LLM realizes, hey, I need outside data. So the MCP client queries the available servers to see what tools are actually hanging on the tool belt. Step 2 is tool invocation. The LLM generates a structured request to use a specific tool, like running a database query. And step 3 is action and data return. The MCP server executes that secure action out in the external system and then passes the beautifully formatted data right back into the agent's context window. Now, what's really interesting here is the hard data. This perfectly illustrates exactly why the industry is abandoning native per vendor function calling and moving to MCP. Look at the time to integrate metric. Wiring a new SaaS tool into an AI agent used to take an average of 18 hours of custom coding. 18 hours! With MCP, that drops down to 4.2 hours. Plus, it is completely model agnostic, meaning you can just swap out the underlying LLM without breaking any of your tool connections. And because the tool schemas are normalized per session, it actually results in 31% lower compute costs per tool call. Honestly, it's a massive productivity multiplier. All right, moving into Section 3, ADK, structuring the agent. Basically, the brain of the operation. So we have all our tools wired up, right? But how do we build the agent itself? Shifting our focus over to Google's framework, we have the Agent Development Kit, or ADK. This is an open source system designed for building, debugging, and orchestrating reliable production-grade AI agents. If MCP is the USB cable connecting your computer to the printer, ADK is the operating system actually running the computer. It provides the organizational structure, almost like a company org chart, that lets you move away from messy, chaotic prompt engineering and move into robust software development. You see, ADK forces developers to use very strict defined primitives. You build with agents, which are specific execution units that have instructions and allowed tools. You have memory, which handles both your short-term session state and your long-term user preferences, so your agent actually, remembers things. Then you have events and runners that manage the underlying reasoning loops. ADK treats the agent's context basically like source code, automatically filtering out irrelevant events and tracking token usage so your agent doesn't get overwhelmed and start hallucinating. And crucially, ADK isn't just for these free-thinking, unpredictable LLMs. It allows for highly deterministic workflow agents. Like, if you know for a fact that step A simply must happen before step B and step C needs to run in a loop, ADK lets you use sequential, parallel, and loop-based structures. You get strict, repeatable control over the LLM's reasoning, which makes debugging and tracing behavior significantly easier than trying to decipher some ad hoc spaghetti code made entirely of prompts. That brings us to Section 4, MCP versus ADK. And spoiler, they are not rivals, they are partners. I know the title of this explainer is MCP versus ADK, but as you can probably start to see, that's a bit of a false rivalry. Let's contrast them sharply. MCP is all about vertical integration. It connects agents to tools, and it connects agents to external data. Like we said, it is the USB-C port. ADK, on the completely other hand, is horizontal integration. It orchestrates the agent's internal logic, it handles the memory, it manages multi-agent coordination. If you think about a microservices architecture, ADK is the internal company structure deciding who does what, while MCP is the internet connection allowing all those workers to actually look up information in the outside world. Okay, Section 5, building the complete stack. Let's look at a real-world scenario. So how do we take the horizontal logic of ADK and the vertical connectivity of MCP and actually smash them together? Well, imagine you're building an enterprise AI coding assistant. You would use ADK to orchestrate the core reasoning loop, the planning phase, the memory management, and the retry logic for when the code inevitably fails the first time. And because ADK natively supports Google's A2A or agent-to-agent protocol, your main ADK orchestrator can seamlessly delegate tasks horizontally out to specialized sub-agents, like maybe a testing agent or documentation agent. But when those ADK agents actually need to read the code, open a file, or push a commit, they rely entirely on external MCP servers to vertically access your repository and test runners. And this brilliantly illustrates the core takeaway. To quote one of our sources directly, MCP solves this connectivity problem, and ADK solves the orchestration problem. Different layers, but complementary roles. They literally aren't competing for the same job. When you use them together, they create an incredibly powerful, interoperable AI ecosystem that's capable of automating hugely complex enterprise workflows reliably. So I'll leave you with this final thought to chew on. As you look at scaling AI within your own projects or your own enterprise, will your next AI system be a fragile, chaotic web of custom code and one-off API connections? Or will it be a structured, highly capable ecosystem built on the complementary foundations of MCP and ADK? The tools are available, they're open source, and they're ready to deploy right now. Thank you so much for joining me today as we unpacked this source material in today's explainer.